today we will be presenting about pressure instrument and application. So first, I'll start up with pressure. What is pressure? So, pressure is the force applied per unit area. And the formula is pressure equal to force divided by area, or P equal to F divided by A. And the SI unit is Pascal, also known as PA. Pressure is everywhere in our daily life. For example, when you pump air into a bicycle tire, use a water hose, or even drink through a straw, pressure is involved. And in industry, such as oil and gas, pressure is even more important because it helps operators monitor and control industrial processes safely, and pressure sensors detect pressure inside the pipeline or tanks and send signal to the control room.
It converts the pressure to a small electrical signal that is transmitted and displayed. These are also commonly called pressure transmitters because of this. Two common signals that are used is a 4 to 20 milliamp signal and a 0 to 5 volt signal.
This helps operators avoid equipment failure, improve efficiency, and importantly, will maintain the safety.
Now I will explain how pressure is used in instrument technology. So pressure instruments are used to measure, monitor, and control pressure in industrial systems. In industries like oil and gas, pressure is very important because high pressure can damage equipment and causes accidents. One important principle is Pascal law. It states that pressure applied to a confined fluid is transmitted equally in all directions. This principle is used in hydraulic presses, hydraulic jacks, braking system, and pressure calibration equipment. Pressure instruments use sensing elements such as burden tube, diaphragm, bellows, and strain gauge to measure pressure. This instrument help operator know whether the pressure is safe or dangerous. So pressure instruments are important to improve safety and ensure the system works efficiently.
Hydraulics is a technology involving the use of a liquid to transmit energy. This is where Pascal's law takes effect. If a force F is applied over an area A to a liquid in a closed container, the same pressure P is generated everywhere and in all directions of the liquid. This can be used to leverage the transmission of force. As the pressure is uniform at any point, the force applied once can be used on a larger effective area. Hydraulic systems work according to this principle. The transmission medium is in a tank. In most cases, it is a hydraulic oil. The oil is sucked out of the tank and pumped into the circuit using the pump. This is how mechanical energy is converted into pressure and volume flow. Valves control the flow and the direction of the hydraulic fluid in this system. In this way, they control the transmission of force and the direction of the oil flow. In the actuator, the pressure and volume flow transmitted by the pump is converted back into mechanical energy. Cylinders or motors can be used as actuators. The liquid flows back into the tank and has completely passed through the circuit. In practice, these basic components of a hydraulic system are often supplemented with additional elements such as filters, oil coolers, or pressure accumulators.
Now, I will discuss the application of common pressure instrument in hydraulic and pneumatic system. First, let's understand the difference between hydraulic system and pneumatic system. A hydraulic system uses liquid, usually oil, to transmit pressure, and pneumatic system use compressed air or gas, but Hydraulic system produce much higher force than pneumatic system. For example, hydraulic systems are commonly used in excavator, hydraulic lift, car brake, and industrial press. Meanwhile, pneumatic systems are commonly used in air cylinder, factory automation, packaging machine, and air-powered tool.
Oh my God!
Pressure instruments such as pressure transmitter and pressure gauge continuously monitor this system. If the pressure becomes too high or too low, operator can immediately take corrective action before equipment fails. Let me give you a simple comparison. Hydraulic is like squeezing water inside a closed pipe. Pneumatic is like inflating a balloon using compressed air. One uses liquid and another one uses gas, but both use pressure to perform work.
Most people think hydraulics and pneumatics are niche industrial topics used only in factories, but the truth is that these systems exist to solve a brutally practical problem: how to transmit force and motion smoothly, safely, and controllably when mechanical linkages aren't ideal. Long before automation, humans were already using fluid pressure to multiply force and control movement. To see this clearly, imagine a simple everyday situation where you use a hydraulic car jack. With very little effort on the handle, a heavy car lifts off the ground. Without realizing it, you've just applied the core principle behind hydraulics: force amplification using fluid pressure. What's actually happening here is simple. Fluids transmit pressure uniformly. In hydraulics, an incompressible liquid transfers force efficiently, allowing small input forces to create large output forces. In pneumatics, compressed air is used instead, faster, cleaner, but less precise due to compressibility. Hydraulics are used where high force and accuracy matter. Pneumatics are used where speed, simplicity, and safety are priorities. This same logic operates at an industrial scale. Excavators and presses rely on hydraulics, factory automation uses pneumatic cylinders, aircraft braking systems use hydraulic power, and assembly lines depend on fast pneumatic actuators. Engineers choose between hydraulic and pneumatic systems based on load, speed, control accuracy, cleanliness, and maintenance requirements, not preference. The scientific foundation of fluid power systems is rooted in Blaise Pascal's observation that pressure applied to a confined fluid is transmitted equally in all directions. This principle made it possible to design predictable, scalable force systems instead of relying on brute mechanical advantage. Now that you understand the intuition behind hydraulics and pneumatics, the next natural step is to explore components like pumps, compressors, valves, actuators, and control circuits, where we break down how engineers design fluid power systems that are powerful, responsive, and reliable. And that's exactly what we'll cover.
Hi guys, so my name is Liyana and today I'll present to you guys about the pressure gauge. But before we get started, let you guys know what is pressure gauge, how it's functioned, what is the pressure gauge working principle, and why pressure gauge is very important in oil and gas industry. So without wasting any time, let's check it out. So let's be started for the first one, the definition of pressure gauge. So what is pressure gauge? Pressure gauge is used to measure the pressure of gas or liquid in container, pipeline, or system. So why is this pressure gauge very important, and how is function? And what is the main focus of the pressure gauge? So to know about this, let's move on to the next video. So in this video, I'm gonna tell you guys the main function of pressure gauge until why this pressure gauge is very important. So there are few functions for this pressure gauge. So for the first one, pressure gauge used to measuring pressure accurately. Number 2, pressure gauge monitoring system performance. Number 3, pressure gauge used to detecting abnormal pressure. And for the last one, pressure gauge used to prevent the equipment from damage by detect the pressure of equipment in oil and gas industry. So, what is the importance of pressure gauge in oil and gas industry? But pressure gauge is not only important in oil and gas industry, but also in another industry. So this is the few reasons why pressure gauge is very important. So the first one is to monitor pressure in pipelines and equipment, to prevent overpressure and accident, to ensure separation, to detect leaks and other product failure, to protect equipment from damage, to maintain the efficiency of production, and for the last one is very important is to meet the safety standard of oil and gas industry. So, did you guys know the burden tube pressure gauge is a common pressure gauge because it's simple, reliable, and affordable pressure gauge. But there's also another type of pressure gauge, including diagram pressure gauge, capsule pressure gauge, and digital pressure gauge. So, now you guys already know the common type and the other type of pressure gauge. But did you guys know how this pressure gauge principle works? So, to know about this, so let's move to the next.
From oval to circular, and this tends to straighten out the tube. The tip of the burden tube is connected to a segmental lever through an adjustable link. The segmental lever end on the segment side is provided with a rack which meshes to a suitable pinion mounted on a spindle. The segmental lever is suitably pivoted and the spindle holds the pointer. The resulting movement of the free end of the tube causes the pointer to move over the scale.
In In this video, I will let you guys know where you can find this pressure gauge, especially in oil and gas plants. So, pressure gauge are commonly installed with a specific equipment such as pipelines, pump, compressor, boilers, storage tanks, and pressure vessels. So, in our daily life, where you can find the common example of this pressure gauge? So, the answer is car. Why? Because car uses a speedometer to measure the speed to help drivers stay within speed limit. So I think this is all from it, and I hope you enjoyed this video and pay more attention in this video. So that's all from me. Thank you.
In conclusion, pressure is an important concept used in many industrial applications. Pressure instruments help measure and monitor and control pressure to ensure system operates safely and efficiently. In hydraulic system, pressure is transmitted through liquid to produce high force for heavy-duty applications. In pneumatic system, compressed air is used for fast, clean, and reliable operation. Pressure gauge and other pressure instruments allow operator to monitor system conditions and prevent equipment damage and maintain safety. So therefore, understanding pressure instrument and the application is essential for engineers and technicians in modern industries. Thank you for your attention.